Hi everyone, thank you for staying here until the end of the day. I know it's been a lot of presentations. So I'm Abby, and I'm going to tell you about some work I did with some co-authors at Facebook AI Research. So when you think about natural language generation tasks, I imagine them as existing on this task spectrum. So on the left, you have tasks which are relatively less open-ended, such as machine translation. And on the right, you have the tasks which are more open-ended, like chit-chat dialogue. So when I say open-ended, I mean that with machine translation, there's only so many ways you can, in a valid way, translate the given sentence. Whereas with dialogue, there is a much, much larger space of things that you could say that would be a valid response. You could also phrase this as saying that on the left, you have tasks which have more kind of low-level, word-level decisions in order to solve the task. Whereas on the right, you really have to do a lot of high-level decisions to make a good choice. So I know that machine translation does indeed have many high-level decisions, but if you do a kind of word-by-word translation, you do have a kind of working baseline. Whereas with story generation or chit-chat dialogue, you really do even just have a working baseline, make some high-level decisions about how you want to respond, what do you want to talk about, or maybe where the story is going. I think you could also say that at least so far, neural language models have been more successful for the tasks on the left than the right. That's partially because the recent seek-to-seek systems that have been successful have been developed for machine translation, and the community is figuring out how to apply them to other more open-ended tasks. But as things stand right now, I think you can say that seek-to-seek style approaches have been more successful for the left tasks than the tasks on the right. I would argue that control is more important for the tasks on the right. So when I say control, I mean the ability to specify some kind of desired attributes of the output text at test time. So for example, you might want to control in a dialogue agent the kinds of things it talks about, or when it decides to ask questions, or when it decides to change the topic, and so on. And similarly, you can imagine in story generation, you might want to control certain aspects of where the story is going, maybe, a kind of overview of the plot. Lastly, I think another big difference between the tasks on the left and the right is that, as we know, evaluation is pretty difficult for all natural language generation. And even in machine translation on the left, evaluation is still totally not trivial. So we use blue, but we know that blue is not perfect and might be getting even more kind of insufficient as the models get better. But on the right, it's an even worse situation. Metrics like blue and rouge aren't even really a good baseline, even for the tasks on the right. So eval is super hard for the tasks on the right, and that's partially what this paper is about. So, after saying how hard all of this is, this paper is in fact about chit-chat dialogue. So we're trying to deal with all of those problems on the right. So the research questions of this paper are, we are going to try to control multiple attributes of the generated text. Remember I said that being able to control aspects of the generated text is important, so we're going to try to do that. And then we're going to use humans to evaluate aspects of the conversational quality. So we're trying to see what's the connection between controlling different aspects of the text and how humans perceive the quality of the conversation. So our first research question is, how effectively can we even control these attributes in the first place? And as a preview of the answer, we find that we can actually do that pretty well, at least for the attributes that we try to control. But we did find that different methods work better for different attributes. Our second research question was, how do these controllable attributes affect the quality of the conversation? So again, we found some strong connections here. And in particular, we found that it was very important to control the level of repetition in the generated text, how specific versus generic it was. And we also found that it was important for the quality of the conversation to control our rate of question asking. Our last research question was, ultimately, can we use this kind of low-level control over the text to make a better chatbot overall? And here, preview of the answer is yes, but we should be careful how we define better overall. So I'll come back to these questions later in the talk. So first I'll introduce the task that we were tackling here. The persona chat task and dataset is a chit-chat dialogue dataset that looks something like this. You have two participants who will assume one is a human and one is a bot, and they each are given at the beginning of the chat a persona, which is a short collection of personal attributes. And then the two are supposed to have a kind of getting to know you style chat in these two personas. So this dataset was collected from Turkers who were asked to do this task, and now our job is to try to build a bot that can talk in this setting. So remember I said that we want to wanted to control several attributes of the generated text. And here are the 4 things that we tried to control. So firstly, we want to control the level of repetition, and our main goal here is to try to reduce the level of unnecessary repetition in our bot. Secondly, we want to control the genericness versus the specificness of what we're saying. So when I say genericness, I mean saying things like, oh, that's cool, which are very generic responses that you can say in many different scenarios. Thirdly, we want to control the response relatedness of our utterances, and this is basically how related is what you're saying to what the user just said. So maybe if you're changing the subject, then that means it's not very strongly related to what the user just said. So here, our main goal, our motivation for doing this is we wanted to try to respond more on topic, more based on what the user said, and don't kind of ignore what the user said and change subject unnecessarily. Lastly, we want to control the rate of how often we ask questions in the dialogue. And really here, we're just trying to find out what is the optimal rate of question asking in this task. So we're controlling these attributes of the text, and then we're also asking humans, Turkers, what they thought of the conversation. So we do a pretty fine-grained evaluation here, and we ask them about the 6 aspects of conversation. So we ask about some pretty obvious stuff, like did the bot repeat itself? That's something which we can try to measure automatically, but there's some more kind of subtle types of repetition that aren't as easily measured. So we ask, did the bot repeat itself? Did you find it interesting to talk to? Did it make sense? Did the bot use English naturally? Did the bot seem to be paying attention to what you said? This one's an interesting one, whether the bot was listening, because listening is quite a hard thing to kind of concretely quantify. Like, what does listening look like? So in any case, we asked Turkers whether they thought that the bot was paying attention. And then lastly, we asked, did the bot ask an appropriate amount of questions? So after all of this, we finally have 2 overall judgments of overall quality. And the 2 we use here are humanness, aka a kind of Turing test. At the end of the conversation, we say, do you think you just spoke to a person or a bot? And they give, certainly a bot, certainly a human, or probably a bot, probably a human. And then we also asked, was the bot enjoyable to talk to? Okay, so that's our evaluation pipeline. Here are these methods that we use to control the output of the generators. So we used 2 existing general purpose control methods, meaning that these are methods that allow you to control any kind of measurable attribute of the text. So our first method for controlling the text was conditional training. This is pretty simple. The idea is that you want to train the model to generate the text Y, conditioned on the input X. So far that's just seek to seek, but you also want to train it to produce the text Y, conditioned on the desired output attribute Z. So the idea is that if you say Z says that, I want you to ask a question, please, then the model will learn to produce something which is a question. And then our second method is weighted decoding. This is more of a kind of late intervention. So the idea is during decoding, that is when you're actually generating the text word by word at the end, you want to increase or decrease the probability of generating words with particular features. So the idea here is that, let's say you want to say something that's more generic or more specific, then you might kind of give, up weights or down weights to certain words because they are more rare or more frequent, or whatever it is you want. So those are the 2 methods we use. And here's how we found they were effective or ineffective to control the attributes of the text. So the first one, conditional training, that's when it's trying to learn to produce the text with the desired attribute. We found that this didn't work great for controlling repetition, because the whole idea of conditional training is you need training data that shows the attribute you want to control. So given that repetition is mainly a problem that happens with the models kind of at test time, we didn't really have the repetitive training data that we needed in the data set as it stood. So that didn't work great. And then we also found that, somewhat disappointingly, it didn't seem to be able to learn very well what it meant to kind of change the subject or say something that was very related to what the user just said. However, we did find that it was pretty effective for controlling the specificity versus genericness of the utterance, and then also whether it was a question or not. That was pretty reliable, and I'll show you examples of that in a minute. For the other method we tried, weighted decoding, that's the one where you kind of increase or decrease the probability of certain words at test time. We found that this doesn't work naturally for controlling question asking, because question asking is more of a kind of, sentence level, utterance level attribute, not really a word by word one. But for the other attributes, we found this worked pretty well. So I know this slide's pretty abstract. Let's look at some examples. So here we are trying to control specificity. So in this scenario, the input, that is what the user just said, they said, I'm studying law at the moment. So our baseline model just says, that sounds like a lot of fun, which is kind of okay, but it's not really that specific, it's a bit generic. So here you can see an example of what it looks like when we control the specificity versus the genericness of our response using this weighted decoding. So when we turn up the specificity knob really high, then the whole thing just gets completely broken, and we just output all of the rarest words we know, which is just nonsense. And when we turn it down really low, then we say, oh, and a lot of dots, because that's the most generic thing. But I think the thing in yellow is kind of the best one on this slide. That sounds like a lot of fun. How long have you been studying? Which is a bit more specific. So if you can kind of get the knob just right, then maybe you can get something which is better than what the baseline gave. So that was the top one is the weighted decoding method, and then at the bottom we have the conditional training method. And then similarly here, we're able to get a range from more generic to more specific. So overall, we found that for these two methods, the weighted decoding method, that's when you kind of change the word-by-word probabilities. This gives you a very large range with very different extremes, but the output is pretty nonsensical at the two extremes, so you have to be quite careful. Whereas with the conditional training method, that's the one where you're training the model to give something with the desired attribute. It has a smaller range, but it's pretty well formed. It's fairly safe at both ends because it's not going to learn something crazy because it was all based on the actual training data, which was reasonable. As another example, we are controlling here the relatedness of what we're saying to what the user said. So in this example, the user said, do you get coffee often? And the baseline said something that wasn't really very related. I do when I'm not playing the piano. That's probably because the piano was in the persona. So here you can see we're controlling how related what we say is to what the user said. So we can say something super unrelated, I'm a musician, or we can turn it up and say something which is supposed to be very related but doesn't really make sense either. So when we turn it up to very related, we say not often, usually with drinks, espresso, latte, tea, etc. So there it's essentially just trying to maximize the reward that we're giving it by writing as many kind of coffee-related words as it can, which clearly isn't right. But I think the middle-ish response, I do, usually at Starbucks, to do you get coffee often, is actually a good response that's more on topic and more related to what the user said. So our second research question was when we change these attributes of our generated text using control, how does that affect the human's evaluation of the quality of the conversation? So to give a high-level kind of summary of what we found that when we reduced the amount of repetition, this had a good effect on pretty much all of the metrics, and that really tells you more about the baseline, that the baseline was way too repetitive. Secondly, we found that when we increase the specificity, so that is make it less generic, make it more kind of a human level of genericness, then we got better scores of interestingness and apparently how much we seemed to be listening, and then it was also more engaging overall. Although we did find that we got slightly worse scores on making sense and speaking English naturally, probably because we were generally taking more risks with what we were saying, therefore sometimes we went wrong. We also tried increasing the response relatedness, that is saying things that were more on topic for what the user said. Interestingly, this didn't actually work out well for increasing any of our human evaluation results. The main losses were that we, again, got worse making sense and fluency scores and then worse overall judgments of quality. I'm not sure exactly why this is. I think it was that, again, kind of saying things that are more related to what the user said means that you have to take more risks. It kind of raises the bar for saying something that actually makes sense and logically follows on from what they said. So that didn't work out in this study. And then lastly, we tried controlling question asking. So we were able to control whether we ask questions, none of the time or all of the time and several points in between. And then here we found that when we increased our question asking rate to about 66%, and that's more than our baseline, and it's quite a lot more than the humans when they talk to each other, we found that this gave an improvement in several scores. So apparently this was a more appropriate level of question asking, it was voted more interesting and more engaging. So I think maybe the takeaway here is that people like talking about themselves, so if you ask them lots of questions, then they rate that better. Our third research question was, can we use these controls, find the kind of magic combination, to get a better chatbot experience overall? So the first answer is yes. By controlling these, the three attributes that actually gave us improvements, then we get better engagingness, that was the enjoyability metric. We get better engagingness ratings that are kind of approaching the human level. So by that I mean our bar there is close to the yellow bar. However, when we ask people about this humanness metric, are we having conversations that seem more human, then the evaluations were very, very far from the human level. So this means that our bots were almost as engaging as humans, but they were clearly not human. So people weren't really fooled, but they said that it was still a pretty enjoyable experience compared to the other humans. So, So I'm going to say another thing about this. So I think one thing you have to be careful with here is, what does this human bar mean? This yellow human bar was measured from getting Turkers to talk to each other in this artificial task where they had to take on a persona that wasn't theirs and talk to each other for about 6 to 8 turns in this way. So I think one thing that's interesting is that maybe that's not actually a very engaging task in itself. It's maybe not that enjoyable in the first place, so perhaps humans give each other pretty poor enjoyability ratings simply because they're not actually having a real conversation for fun, they're doing a conversation, for payment. So I think you have to be very careful here when you we could claim victory, right, and say that we're just as engaging as humans as conversationalists, but I think more accurately, we're about as engaging as humans doing this artificial task for payment rather than fun. So I think we have to be careful here and draw that distinction. So in any case, here are the conclusions from this work. So firstly, we found that control seems to be a good idea if you're building a neural sequence generation dialogue system. I'd recommend that controlling for these different attributes and maybe some others could be a pretty sensible and somewhat reliable way to get better results. We found that using some fairly simple control methods and controlling a few fairly simple attributes, we matched the performance of, this part I took out, but essentially we got some human evaluation metrics that were pretty similar to a model that was trained on a lot more data. Thirdly, this might be obvious, but don't repeat yourself, don't be boring, ask more questions. These seem to be fairly good rules of thumb for having better conversations, whether you're human or a bot. Fourthly, we found that these multi-turn phenomena, like noticing if you're repeating yourself across utterances or how often you're asking questions over the whole conversation, these are all pretty important to conversational quality. So you need to evaluate your chatbot over several turns in order to detect these things. We noticed that engagingness is not the same thing as humanness. Apparently we were quite engaging, but not very human. So you should think carefully about which of these you might use as an overall evaluation metric in your chatbot. Lastly, we think that perhaps paid Turkers talking to each other are not the most engaging conversationalists and maybe not the best judges of engaging conversation either. So perhaps it would be better to try to somehow use humans truly chatting for fun as a better kind of metric or a bar to meet in terms of actual conversational quality. Thank you. Yep.
Did the female bots ask more questions? Because we know males don't never ask for directions.
Did you ask, do the female bots ask more? What does female bots mean?
Thanks very much.
Okay. Okay.
Whether they're more male or female. Like the female ones might ask more questions and be more conversational. Go figure. But seriously, do you actually look at gender in these things when you evaluate these? Would you control gender as a variable?
So I think our main concern here was how do humans, and humans is the humans who were Turkers, perceive the quality of the conversation given the expectations of the task. So no, we definitely didn't have access to data like the gender of the Turkers.
No, the gender of the bot I'm talking about, because it's an attribute you can control, the gender of the bot.
What do you mean? Oh, I see what you mean. Okay, so you're saying like we want a control knob that says what is the gender of the bot.
You hadn't done the experiment yet, but if you had varied the gender of the bot, just speculate or just tell me to go away.
Right. So I can.
There's a lot of opinion about this. People think genders matter.
So you can imagine a scenario in which perhaps we get a bunch of training data from social media where we do know the gender of the people talking, and then we could try to train models that generate text in the style of people who I self-identify as different genders. I would bet that, yeah, those things are perceived differently. But I think it's a kind of a dangerous path to go down to kind of assign genders or gendered personas to bots, and I don't love the current trend where most kind of friendly bots kind of have to be female because people have preconceived notions about how women are more friendly. I think it's a dangerous path to go down when we kind of take that cultural stereotype and then bake it into the bots and thereby kind of perpetuate that cultural stereotype. So we certainly didn't do anything in this experiment, but that's my opinion about that trend in general. Okay. Was there a question here?
Yeah, I was just wondering, the function of W that you're learning, it seems like some of the responses, it is because it doesn't know what words it has already generated. So like coffee questions, it has already generated a lot of coffee words, and the FFW actually does not know that. Is there a way to be in the middle ground somewhere, where you learn these things for a word but also condition on?
So you're asking about like conditioning on the text that you've already generated so you don't overdo it? Yeah, so there are some more sophisticated kind of text generation control methods, you might call them, sometimes using RL. So I don't understand them super thoroughly, but my understanding is that you have this kind of actor-critic model such that based on the generation so far, you kind of like evaluate how much you've like satisfied the constraints so far, and thereby it guides the rest of the generation. So we didn't try that method. It seems like an interesting one, but also quite a hard one to get right, and maybe it has its own problems as well. Yep.
At the beginning of your talk, you mentioned some of the challenges of being on that side of the spectrum, and one of them was high-level structure. Do you have ideas on how we can have control for such structure? Because I think the attributes you were looking for are sort of very local. Are you repetitive or not? But like, what are you trying to get to a point, or are you trying to have certain semantic coherence? Both of these are things that are hard to control but seem like fundamental aspects of that.
Right. Yes. So I think the reason we ended up controlling these fairly low-level, kind of relatively less ambitious things than the whole structure is because those low-level things were enough of a challenge to control that was quite a challenge. But yeah, as for how are we going to control these high-level things, I think there's been some really interesting papers recently, for example, in story generation, about how you might try to give a kind of a skeleton, a plot summary to a story generation model, and then it generates it. So I think there's kind of a lot of work in how would you get these kind of in-betweeny annotations of like what's the high-level structure as a skeleton before you have the actual natural language. As for like how to do the two-part thing where you generate the skeleton and then you generate the text, I think that's really hard as well. And it seems like part of the challenge is tied up with the question of what exactly should even be the representation of that high-level skeleton. So I guess my answer to your question is like that's hard, but I've read a lot of papers on it. It seems to be a lot of interesting things.
Okay, thank you.
All right, thank you.